Hi everyone, welcome to our second seminar. So today's outline, we are first going to talk a bit about assignment 1, and then I'm going to talk about what's the purpose of seminars and assignments. And then third, I'm going to remind you about something that you need to do and something you shouldn't do when you write your script. And then fourth, I'm going to talk about some information about term paper. And then fifth, today we are going to talk more about R. So first, the purpose of seminar is to shortly go through the last assignment and also give you some hints and tools for solving the upcoming ones. And then second purpose is we are going to review some basic statistical and also econometric concepts. And the seminar also can help you prepare for your term paper. Yeah, and regarding the coding of R, so coding is learned by trial and error, so you shouldn't be too frustrated or feel stressed about learning R. So the assignments, so let me repeat the thing that we have already uh, told in the first seminar. So you should, so when you hand in your assignments from like assignment 2 to assignment 4, so you should hand in script and PDF file. The PDF file is for explaining the results, which answers the question, and the script is about the coding that you use to solve your questions. And then assignment 5 is individual, and you should upload your assignments on Athena. And remember that the quality of your assignments will be taken into account for your grade of the course. So you should make some efforts when you do your assignments. And for the assignments 1, so though I haven't finished the grading, after I scanned it a bit, I found out that overall you did a good job on assignment 1. And the things that you should think about when you write your script is that you should run your script file before sending it in. You need to check that your script works, but not like stopped or have any bugs in it. And also when you make some comments about your code, you should have a prefix. Otherwise, the R will regard it as a part of your coding, and which may make the execution of your coding stop. So this is the example. So this is the bad example for the scripts that you hand in. So why is that? So it is because that you didn't explain what your coding is about. So you just like paste your code in the scripts and did not explain. And so this is the thing that we just told. So which I also think it's a really easy mistakes, which but also like easy to make. So just as I said here, so you should, when you make your comments, you need to remind yourself of putting a prefix when you change the line. Otherwise, the R will interpret the comments as a command and execution will stop. So this one is a good example of for your assignments. So first you can see that each question is separate and very clear. And also the purpose of each coding is clear as well. So this one is the good example of your assignments. So now we are going to talk about term paper. So the deadline of term paper, there are 3 deadlines. So the first one is November 16th, so which is a week later. So you need to think about your proposal. So what you are going to do for your term paper. And then the second deadline is on December 8th, so which is the deadline for the preliminary version. And the final and also the third deadline is on January 7th. So on January 7th, you need to hand in your final version. And after that, you cannot do any modifications for your paper. And when you hand in your final version, you need to upload a PDF file, so which is your text for your term paper, and a script file, so which is your command. For example, your commands for doing the regression. And then third one is the data set that you used, if it is not from Ectot. So we will talk about Ectot later, I think. So the preliminary version is presented in a seminar, which is mandatory. And in that seminar, you will get feedback from us so that you can improve your term paper. And if you have some questions about your term paper, you can also seize that opportunity to ask us as well. So since the deadline of first proposal is only a week left, so you should start to think about a term paper. And so, so what you are going to think about your term paper. So in the term paper, there are basically 6 parts that you should contain your term paper. So the first one is a question that you would like to investigate. So, so you need to think about which topic that you are interested in, because economics, there are lots of fields in economics and lots of questions as well. So you need to first pick a question that you would like to investigate. And I think you should also motivate it well. So you need to think about why it is interesting. And for example, what relationship you expect and why. And then the second is since there might be some people who already did the topics that are similar with yours. So you can check the previous literature and studies to get some more ideas. And then the third one is you should explain your data set. So you need to explain, for example, the data source, and for example, like what variables are in your data set. And then the fourth one is you should contain some summary and descriptive statistics about your variables. So for example, plots or tables or histograms, so which we are going to talk about later in this seminar. And the fifth one is the regression results. So of course, you need to present the results of your regression. And then the sixth one, so this one is the thing that I think, the thing that I think is the most important. So you need to have some interpretation and also discussion of your results. Because this part can show your understanding of this course. So I think this part will also account for the most important part in the grading, because it is not that difficult to do a regression, but it is more difficult to interpret the result of regression. Yeah, so basically this is the information about term paper. And of course, we will talk more about it in the future seminars, but you can start to think about it. So this is somehow the recap of what we have taught last week and also what you have done in your assignments. So first, we create a folder in the drive and also call it seminar 2, for example. And then you use getwd so to check your current working directory. And if it turns out that the current working directory is not the folder that you would like to put in, then you can use setwd, so which means set working directory to change your current working directory to the one that you would like to put the data set in and also would like to operate. So now we download. So for me, I create a folder called project 2 in the desktop and set it as the working directory, which I will show later to you. And so now we are going to use LNU91 text for an example. So first, we download the LNU91 text from the web, use the following link, and also save it as the LNU data 91 text. So we use download file command, so which you are already familiar with because you already did it in the assignment 1. So when you use the download file command, you need to be careful that you should put a double quotation mark in both the website, the link, and also the file that you would like to store. And then you can check whether the file is in your working directory using dir command, and also read it into R, and then turn the text to the RDF file, which is the R dataset file. So by using the save command. So now we turn to the R and show you how it works. So now we turn to the R interface. So first, I set my working directory in project 2 in my desktop, and then I download the file, and I call it LNU data 91 text. So I execute it. And then I use dir to check whether I successfully download the file or not. So you can see that in the working directory, now we have the LNU data 91 text. And then now I read it into R using the read table command, which actually you also did it in assignment 1. Okay, so I found out that I used the wrong websites to download the file, so that the R file did not recognize it. And now I already corrected, and also on the slides as well. So the slides that you saw now is already the corrected website. So So let's just continue. And I use the LNU data and I read table. So you can see that's here. And we already read the text into R. So you can see here in environment, it shows that there are 2,249 observations with 6 variables. And then we save it into the RDF file. I think so now when we go to the project to folders, you can see the LNU data text and also LNU data RDF file as well. So as you can see here. So now we turn back to our slides. So this is the last week that we have done. Yes. And then now we are going to talk about how to create the subsets of observations in your data set. Because maybe you are only interested in some observations inside the data set, but not the whole data set. So we are going to use the LNU91 data set to show you how to pick out part of the data set and store the data into smaller subsets. So first, we are only interested in a subset with 2 variables, female and wage. So which means that the number of observations remains the same, but we are only interested in 2 variables. Because, for example, when we go back to the RStudio, you can see that actually there are 6 variables. So when you click, you can see that there are 6 variables in the LNU dataset, so which are wage, school, experience, public, female industry, but we are only interested in female and wage. So how are we going to do it? So we type, so for example, we name the objects coded few variables. And then we use the command called subset. So which is straightforward, which means that to create a subset of the data set. So this is the data set that we are like that, which is the intended data sets that we want to create subset. And then select. So select, which means that the variables that you are interested in. And then the vector command again. So female and wage. So now you can see in the environment here that, so now we create another data set called few variables. The number of observations is the same, but the number of variables is decreased. So now it only contains 2 variables. So when we click it, you can see that it only contains variables, female and wage. So now, what if we are only interested in the observations for women only? So which means that all variables, so there are still 6 variables, but the number of observations changed because now it only contains the women observations. So how are we going to do it? So now we name the new objects called female wage. And then again, use the subsets command as well. The intended data set is the same. And then we type female equals 1. So female here is the dummy variable, so which we will talk about it in a later seminar, but I can talk a bit about it first. So female is a dummy variable, which means that it only contains two values, which are 0 and 1. So 0 means no, and 1 means yes. So female double equals 1 means that the observations is female, which means that the observation is women. So when we type this, it means that I create a subset of LNU data where the female are yes, so which means that the observations are women. So when we execute it, and you can see that in the environment here, it shows that there are new data sets being created. So the number of observations is decreased, which is not surprising. And the number of variables is still the same. So when we click, you can see that now here the female one is only like 1 here. You didn't see any male which have like 0 value in female variable. So you can compare it with the original data set, which is LNU data. So you can see here, for example, the fifth observation in LNU data has the value 0 in the column of female, but you didn't see any observation like this in the female wage data set. And if you want to have more like information about a data set that you created, you can use the str command, which stands for structure. So you type str and then female wage. Then you can see the introduction of the structure of the data set that you create in the console. So now we go back to the slides. So what if now we would like to create a data set called female wage. So I just use up the names. So what if I want to create a data set called female wage, which with only female and wage as variables and women observations? So which means that I would like to combine the conditions for the previous two. So it is also straightforward. So you just combine the previous comments together and just put it in the same parentheses. So you can see the LNU data, female equals 1, and then select C, female wage. Then you can create the data sets which only contains women and also only contains wage as variable. So I will skip this. And then the next one is how we are going to create a data set with the restriction that wage is over 120 crowns per hour. So if you would like to do this, then you can type, for example, I name it high wage. And then I use the same command as subset. So subset LNU data. And then I specify the condition that I'm interested in. So for example here, wage is higher than 120. and then I execute it. So you can see here in the environment shows that there are new data sets being created, so which is high wage. And if you are interested in the structure, so you can use the str command, and we can see that here in the wage, the observations in the high wage data sets are all higher than 120 crowns. So as shown here. So now I'm going to talk about Ecdot. So the package Ecdot contains a lot of useful data sets that you may use for your term paper. So of course, if you want to choose if you want to use the data elsewhere other than Ecdot, it's also perfectly fine. But when you use Ecdot, it actually saves lots of your time. So you don't need to spend time like collecting data by yourself. And when you do a term paper, another thing that you must remember is that you shouldn't use time series data, only cross-sectional or panel data, which we will talk about it later. But anyway, you shouldn't use the time series. And if you want to use the Ecdot package, so it's just the same when you install our packages. So you just type install packages Ecdot, and then load it, use the library package. And if you are interested in the description of the datasets that you would like to use inside Ecdot, you can click this link to also think about what topics that you are interested in and what data set you can use for your topic. And then you can use the data commands to list out all the data sets, each with a short description. So for example, now I'm going to load the wage data sets, then I can type data wages. And then if I want to know more information about the data set, then I can type summary wages. So I will show you now in RStudio. So now we are going to install Ecdot. So install packages. And then now we are going to load the library, Ecdot. And then by type data, then we can use the data set called wages. And then if you are interested in the data set that you import, then you can use summary. So now you can see the information of the data set that you import. And you can also see here wages. So which is the data set that we just import. So this is how we use the Ecdot and also the data set that you're interested in Ecdot as well. So now let's go back to the slides. So now we are going to introduce how to draw the histograms and also plots in RStudio. And we are going to use the CPS CH3 package, dataset in Ecdot package. So since we already download and also execute the library Ecdot, so we just use data and then CPS CH3. And then if you want to inspect the data sets, the CPS CH3 data sets, then you can use SDR, just as we said a few minutes ago. And then attach it before working with it, because we are going to draw the histogram and also plot it. So to draw the histogram, we use the command called hist, which stands for histogram. And of course, not surprisingly, we use plot command to draw a plot. So plot stands for plot, which is also straightforward as well. So now when we go back, so now we would like to use the dataset called CPS CH3, and then we type data CPS CH3. So you can see here, so there are only 3 variables in CPS CH3, so which contains more than 10,000 observations. So if you are interested about it, you can take a look. So the CPS CH3 contains only 3 variables, which are year, wage, and also sex. So when we use the SDR command to take a look at it, so you can see here as well. And then now we are going to, so before we draw the plot and also histogram, so we use the attach command to do it. So now we can draw the histogram. So first, we would like to draw the histogram of the wage. So we use hist and the AHE. So you can see here. So the plots will appear in the lower right corner of RStudio. So you can see that this is the histogram of HE. So most of the observations have the observations have the wage between 10 to 20 here, because frequency here means the observations. So which means that most of the observations here are in, most of the observations have the wage between 10 to 20. And of course, you can add some more conditions for the histogram that you would like to know. So for example, now, you would like to limit the y-axis up to 4,000. Then you can type AHE and then y-lim, so which stands for the y-axis. So range stands for range, and then between 0 to 4,000. So if you do it, you can see that here. So now the ceiling is only 4,000. And of course, you can add even more conditions for the histogram that you would like to create. So now, for example, you would like to show the relative frequency, so as a probability. So you can type prob or probability equals true. So if you do that, you can see that now it becomes density, so which stands for the probability. But before you're doing it, it shows the frequency, so which is the absolute number. And of course, for example, you want to only create the histogram for female, then you can type 6 equal female. So double equal sign. So this is the histogram for the female. And now, for example, and now you want to plot the wage, then you can type plot AHE. Then this is the plot. And you can also plot two variables together. So which is wage and 6. So you can see that because they are either male or female in the data set. So you can see that it's really extreme. So it's either 0 or it is either 0 or 1 when it comes to sex. But in female or in male, there are like different kinds of wages in the distribution of AHE. So it just looks like this. And you can change the position. If you want to see the distribution of sex and wage as well. So here, when we put the sex in the first position, so the sex is on the x-axis, and the second position is for AHE, so which is for wage and also for y-axis. So you can see here, most of the observations, either in male or female, are concentrated between 10 to 20 dollar crowns. But so this is how we draw the plot. So now we come back to the slides, and now we would like to create the tables and also like cross tabulations. So first, if we would like to know the numbers of observations by sex, then now we can use the table commands to create a table, so which is also straightforward. And then if you would like to know the relative frequencies, so which is the probability of sex in a data set, then you use the table of sex divided by the length. So which is also quite straightforward. For example, if there are 10 observations and there are 4 females and then 6 males, so which means that the probability for you to, if you want to only pick one observation, and the probability for you to get female is 0.4, which is 4 divided by 10. So the idea is the same when you use the comment. So when you use the table 6 divided by the length, so which means that then you can get the relative frequencies of 6 in this data set. And if you want to, you can also draw a table for 2 variables at the same time. So for example, if you would like to know the number of observations by sex and year, then you can type table, parentheses, sex and year, and the same for the relative frequencies as well. So which here will be the joint probabilities. So which means that now it's not the now it's not only the probability of one variables but also 2 variables at the same time. But the idea is the same. So you should also divide it by the length of year or the length of 6 because they have the same observations. So it doesn't matter when you use length of 6 or length of year. So, and if you are only interested in the first columns, then you can use the sum, so which stands for the summation. So which I will show you an example. So now let's get back to the RStudio. So now let's create a table for sex first. So you can see here in the console. So there are 5,956 male and 174 females in this data set, in the data set CPS-CH3. And then if now I would like to know the relative frequency, then I divide by the length of 6. So you can see that the probability for me to get male when I only pick one observations is 0.53, and the probability of female is 0.46. And of course, I can draw a table for 2 variables at the same time. So 6 year. So you can see that there are 4 different years with 2 different genders. So this is the table for sex and year. And if I'm interested about the joint probabilities of different years with different sexes, then I can do it the same. So I name it joint probability. And then I use table sex and year divided by length, year. So now what if we would like to know, so let's turn back to the slide. So now what if I'm interested in the first columns? So before we name it to objects, I will show you here. So what if we would like to get the values of the first columns? So which is, what if I want to know the value of female with year of 1992 and also female with year of 1992. So what's the probability of I getting the male in 1992 and female in 1992. So to do it, we use the summary command. So sum, and then 6 equals male. Since we know we have two conditions, so we need to use AND to connect them. And year 1992 divided by length year. Wait a second. So you can see that now we get the value of male in 1992, so which are the same here. So it is, so here we first find the number of male in 1992 and then divide it by the length of year. And if we want to know the probability of female in 1992, so we use summation 6 double equal sign female year 1992 divided by length of year. So you can also get the probability of getting the male in 1992 if I only pick one observation from the data set, so which is 0.12, which is the same as here. So this is how we create a table and also calculate the probabilities inside. So now we are going further, and let's turn back to the slide. So what does this tell us? So for example, we just see that the first row and the first column. So let's turn back. So what does this tell us? I mean the 0.1429. So what does this tell us? So just as I said, so this is the joint probability of male as year of 1992. So which means that if I would like to pick up an observation from the data set, so what's the probability for me of getting the male in year 1992? So which means that the 14% of the individuals in the sample are males observed in 1992, which also means that if I would like to pick up one observation in a data set, the probability for me to get the males observed in 1992 is only 10%, about 10%. And you can see that if we sum up all the joint probabilities, it will become 1. I mean, it's also straightforward as well, because if we sum up all the possible combinations, so if we sum up all the males and females and also all the years in the data set, which means that the probability of pick up one observations in the data sets which have all possible characteristics is always 1. So which is also straightforward. Then the next question is, now we know the joint probabilities in different years with different genders, but what is the marginal probability for females? So now I only concerns female. but I didn't concern for the years. So I only, so I would like to know the probabilities of females. So you can see that if now we did not concern for years, but also females, then actually we can just simply sum up females with different years, right? So the slides just shows this idea. So if now we go back to RStudio and take a look at this table here. So now if we are only concerned for female, so which means that I didn't care about the years at all. I only cares about females. So I just simply added them up, right? So if we want to do this, then we can sum up prop 1. So since we already created an object for joint probabilities for this table, so now when we sum up the joint probability, so it should be 2, 1, because this is the second row and the first column. And then so 2 and 2, 3, and then 2, 4. So if I sum them up, and you will see that the answer of this is 0.464. So which means that this is the marginal probability of female. So which means that there are 46% of female observations are female in this data set. So which is also actually the same in the beginning when we calculate the probability of sex only. So which is also 0.648697, so which is the same. And actually we can name it as the marginal, and if we would like to store this value, so we can name it as marginal probability of female. So follow this logic. So if we would like to know the marginal probability of male, so we can either sum up the joint probability, or we can actually just directly use the table sex divided by the length of sex here to know the marginal probability of male. So if we would like to know the marginal probability of male, then what we do is that, so we just change the position of matrix inside of the table. So make it becomes 1, 1, 1, 1. So the brackets means the position inside the table. So the first position inside the brackets is for row, and the second position inside the brackets is for column. So for example, this one is 1, 1, so which means that the first row, first column. So before we store the value into the objects, we can first check the summation to show that our understanding is correct. So you can see that the marginal probability of male is actually 0.535. So it's actually the same as the marginal probability of male that we calculate by using the table sex divided by length sex here. So they are the same. And now we store both of values into the object. So now let's go back to the slides. So what if we would like to know the conditional probability of year 92 given male observations? So which means that now I know which means that knowing that an observation is a male, then what is the probability that this observation is from 1992? So you can see that now the condition changes. So before this condition, so the so before this condition, we don't know the gender of the samples. But now, since that we know that an observation is male, then what is the probability of this observation is from 1992? So the way that we calculate for the conditional probability is that we should use the joint probability. For example, in this example is that we should use the joint probability of both year 1992 and male divided by the probability of knowing that the observation is male. So this slide is just for showing the calculation how we do it. So since we know that the male is for 1, 1, then we use the joint probability of 1, 1 divided by the marginal probability of male, which we just calculate. And then knowing that a randomly picked observation is a male, then what is the probability of this observation is from 1998. So the idea is the same. So you should use the joint probability of both female and 1998 and then divide it by the probability of female, because now you know that the sample should be a female. So this is how we use R to calculate for the conditional probability, marginal probability, and also joint probabilities. So you can play with this calculation by yourself. For example, if you would like to know, given that you know that the observation is from year 1992, then what is the probability that this observation is male? So in this condition, then the joint probability is the same. So it's still like male and 1992. But the thing that you divide with just changed, because now the known information, so the information that you already knew just changed. So it's changed from an observation is a female to an information showing that an observation is from 1992. So now you should use the joint probability of year 1992 and male divided by year 1992. So this is how we use the R to calculate the probabilities and also to drawing histograms and plots, so which you may need to use in the next assignment. So now this is the end of our seminar, and thank you for listening.